Hello and welcome to Teaching Mathematics. Today we're joined by Craig. Hello, Craig.
Hi, Helen.
Welcome back. It's been a while.
It has, but it's good to be back. Thank you.
It's always good to have you. And we've got Dylan behind the buttons. Welcome, Dylan. Okay, so today we are talking about finance, growth, and decay.
That's right.
For grade 11s.
Yep.
Now, you have come to us before and spoken about it for grade 10s as well, so occasionally we'll refer back to that show, and we will put the link into the blog, but also you can go and find the past shows. If you go down to watch past mathematics shows, you'll find them there, and viewers can see what you've said before. Sure, got that right eventually. But it has been a while since that show, so why don't you remind us, who are you and why do you know so much about teaching financial maths?
I work at WITS in maths education, and I don't know that I know so much about teaching maths, financial maths, but I've thought a lot about it, so let me not presume to know stuff, certainly in terms of the classroom. When I did my PhD, I focused on teachers' knowledge for teaching financial maths, and so that's given me a lot of time to think long and hard about these things. And so now what's exciting for me is being able to talk to teachers about it and not just theorize about it. And so,
Yes.
It's really getting into the classroom practice that for me is important. So I really look forward to the opportunity.
Yes, what is the point in writing paper and research if you aren't sharing the knowledge? So
Absolutely.
it is really great
Absolutely.
to have you here. And
Thanks.
I'm glad you could share it. Remember, you can talk to us by using the hashtag on Twitter, MEMaths, or find us on Facebook, Digital Classroom South Africa, and post a comment underneath the post for today. You'll see it says Grade 11 Finance, Growth and Decay. Look for that post below it. Dylan will be watching both. He will also be watching the chat box just below this window. So scroll down just a little bit where you're watching us now. Enter in a nickname, press login, and you can chat there. Dylan will be watching that too. And if you talk to us, you can win 110 Rand Vodacom airtime. So talk to us. You'll be paid for doing it. Okay, so as you know, I've been reading this book. In fact, you were part of the initial discussion where we spoke about reading this book and imparting its knowledge. We're now on Technique 19.
Sure.
Yes, so we're slowly getting to the end of the book.
It's been the longest read ever.
Yes, thankfully it's just small sections at a time. So step 19 says at bats, which doesn't really make sense in a South African context. So I'm going to read the quote and then explain it. It says, in baseball talk, learn to hit by getting as many at bats as you can. Okay, so in previous shows I've spoken about my nephew who plays a lot of cricket. And he's not really that inspired to study maths, but he is only grade 4, so I give him a little bit of space. Yes. But he was talking about his first lot of exams and how maths wasn't a studying subject. And so he wasn't going to do it. So I said, well, do you know how to bowl? Yes. I said, well, why do you practice? No, because he wants to get better. But you know how to bowl, you can bowl straight. Yes, but he wants to get faster. And that's exactly what this technique is talking about. It's talking about the need to do things over and over and over again until you get fast enough and good enough that you do it without thinking. You just carry on like that. It's a good tip.
It is a good tip. I mean, we would hope that while we're getting proficient at doing them, we're still thinking to some extent about why we're doing what we're doing and how it all works together. And making sure that we're getting them right, of course. There's no point doing 50 compound interest calculations and getting 49 of them wrong.
That
it is
very
important
true.
to check. But you want to get better at maths, you've got to practice. There's no question.
Yeah, very definitely. Now, we do have a jam-packed show, so we're going to whiz through this and not talk about it too much and go straight on to your slide about what's in the grade 11 curriculum. And you've got 3 main points there. You've got compound growth, compound decay, decrease, and timelines.
Okay, so the first one is really one of the key issues that comes in grade 11 that hasn't been there before is multiple compounding periods. And by that I mean that where previously with compound interest we'd only compound annually, now we might be compounding monthly or quarterly or daily or frankly anything else we want to play around with it. And that is a massive shift because it brings in a whole lot of new aspects to the formula. And so that's really important that teachers spend time on that. Quite frankly, I think it should have come in grade 10, and I said that in the last show, but that is a big element of grade 11. And that leads to the effective interest rate, and we'll talk about that later.
Yes.
So I don't want to talk about it too much now. We'll pick it up later. The compound decay and decrease is about, in the financial context, it's about depreciation, which is about things losing value. So as soon as you drive a car off the showroom floor, it starts losing value. You buy a photocopier or a computer, as you use it, it loses value, and so it depreciates. And these are two models of how it depreciates. So that's new in grade 11. And then the other element is timelines, which is not really content. It's more a strategy and a representation. Unfortunately, we don't have a huge amount of time to talk about those today, so I'm going to skip it. But certainly in preparation for grade 12, it's a really important component.
Yes.
And so I would encourage teachers and learners to pay attention to it. And there's a reference to something I've written, which hopefully will be helpful that we can put up.
Yes,
and people can take a look.
Of course. And if you do want more content on timelines, you can always go and check out the Mindset website, check out the videos. There's always that as well.
Right.
Okay, so we're going to spend a lot of time talking about the first two typical errors and difficulties that you have listed on the slide. The first one says language issues, and the second one, poor understanding of percentage. Then you've got 5 formulae listed over there.
So the 2 blue ones are the ones from grade 10, which is simple and compound interest.
Yes.
The 2 orangey, browny ones are simple decrease and compound decrease. So those are new in grade 11. And then the 5th one on the right-hand side is the effective interest rate formula.
Yes.
And one of the things now that arises in grade 11 is suddenly there are 5 formulae, whereas previously there were only 2. And so there's one of the issues we see with learners is they just choose the wrong formula to use. And so as teachers, we need to be aware of there are now 5 options to choose from. It's not a 50-50 anymore. And so we need to pay more attention to getting the right one. And the issue is that they look so similar.
Yes.
The blue ones have got pluses, the others have got minuses. The one's got the N inside the bracket if you want, the other one's got it outside. They're fundamentally different.
Yes.
And we don't have time to talk about the detail. But those are really important things that we know mathematically are different. But to learners, it's kind of, well, the one's in the bracket, the other one's out the bracket. You know, the one's an exponent. The other one is just been multiplied by I. Very, very different in terms of the way you work with them. And so I would encourage teachers to take time to help
Teach
learners
how
to
to
appreciate
identify
the
them.
differences.
Yes, and how to choose the right one.
Yeah.
Okay, the 4th point says errors related to interest rate, not converting interest rate to decimals, interest rate and compounding periods not in the same unit, and rounding errors. These are quite common errors.
I think all teachers will recognize those.
Yes.
So, yeah, you know, they come up all the time. The middle one, the interest rate and compounding periods not being in the same unit, is a new area in grade 11. We won't have had it before because we don't have different compounding periods in grade 10. So we can talk some more about that as we go along and pay attention to the fact to where that is likely to come up.
Yeah.
In one of the examples that we'll do just now.
Now, if a class is struggling to change from an interest rate to a decimal, would you recommend the teacher stop and spend 5 minutes on that?
Absolutely. I mean, you're going to get every calculation wrong if you don't convert it to a decimal. And so it's in the learner's own interest to get it right. So I would definitely take time to help them appreciate that 12% is 0.12. For example.
And 8% is 0.08.
And just to spend some time. Otherwise, they get everything wrong. You know, even though they can do the rest, they're getting it wrong because of a simple mistake.
Yes.
It's something worth investing in, and it doesn't take much time.
No, not at all. And that kind of skill does impact other areas as well.
Absolutely.
So it's worth going. Okay, so the first point was language issues, and now we have a slide on language issues. The first one says attention to preposition related to time.
I talked about this in quite a lot of detail in grade 10, so I would encourage teachers to go and have a look at that if they want to think some more about it. But it's things like for 3 years, after 3 years, in 3 years. We use all of these interchangeably in financial maths, and frequently they mean the same thing. But in everyday speak, they don't mean the same thing. And so we might say, I invest something for 3 years, an amount of money for 3 years, how much do I accumulate at the end? How much will I have in 3 years' time? It means the same thing,
yes.
but we're using different words. So let's not take too much more time on it, but it certainly is something to pay attention to.
Yes, longer stories, more words.
Well, one of the things in grade 11 is that now that we're compounding differently to annually, there's going to be words that explain compounded monthly, compounded quarterly. So already you're going to get at least 2 more words in every problem. But then there's other stuff that comes in as well. Because often you have the interest rate might change, so you have this like 5-line problem, involves 3 calculations. There are just more words to work with. And I'm sure teachers can imagine this as I talk about it. And so I think it's really important to help learners break each sentence down, to isolate the different parts of the problem, isolate the interest rate, how often is it being compounded, just to recognize that this is not going to come easily for them. You know, we all have this word problem phobia in some ways. These are easier in the sense that you kind of know what you're going to do because they're fairly restricted. But nevertheless, learners see them as word problems.
Yes.
And I think we mustn't underestimate then.
And encourage the use of highlighters and
absolutely
circling words and all sorts of things like that. And drawing pictures.
Well, that's where the timeline is useful because you help start to represent it.
Yeah.
There.
And the last point there says new terminology. We've got book value, scrap value, value of an asset. And I know every time I taught this, I would have to write down the definitions somewhere and have them secretly hidden so that whenever I needed to refer to one, I could look like I knew everything.
Yeah. Well, I mean, that's the thing. Teachers are not necessarily finance people. And so one of the things that comes in with depreciation is many of these fairly formal financial terms. And they just get thrown into the problem, and we've got to deal with them. So I'm going to encourage teachers to go and have a look. You can Google these terms. They are out there easily. Make your own list of them. Scrap value, for example, is one that will come up in grade 12 as well, because it's when a piece of equipment gets to the end of its useful life, it still has a value, and that's called its scrap value. You kind of think if you're going to scrap it, it must be valueless, but in fact it's not. So it's that kind of financial language which hasn't come up previously up to grade 10 in most cases, and it's frequently associated with depreciation in grade 11. So that's where it becomes tougher, I think, with the new language.
And we spoke about this last time, about teachers' insecurity about teaching this subject or this section. Because we're maths people, we like working with X's and Y's and functions. This language and stuff like that, it does make us feel insecure.
And the only way we can feel more secure is by getting on top of it.
Yes.
So we want learners to practice stuff. We need to go and make sure. I think you got a great idea, Write them in a place where it doesn't look so obvious, so you can call it out. You recite it, and eventually, becomes part of your own vocab.
I suppose you could even make posters if you
Absolutely,
wanted to.
And you can look on the wall when the learners are facing forward. Put it behind them.
Exactly my thought. Okay, and the next slide says teaching ideas, and we've got 4 teaching ideas that you're going to talk about in quite a lot of detail now. First one is connecting with percentage.
So this links with the grade 10 session. We talked about the importance of percentage and how percentage is one of the areas that causes learners difficulty in financial maths in general. And I'm afraid I'm going to go back to it today in a slightly different way. But I really am increasingly convinced that percentage is where many of the problems start. And so let's go through it and we can take a look at what I've got there. So I've chosen a simple example about a pair of shoes that cost 500 Rand. The price is reduced by 20%. What's the new price? Okay. So straightforward, probably grade 8, maybe grade 9 kind of problem.
Yes.
I think it's particularly difficult. But the point I want to make is that subtracting 20%, there's one strategy that's about subtracting 20% off the original price.
Yes.
So we've got 500, take away 500 times 0.2, which is the 20%. It gives us 400. The other option is calculating 80% of the original price.
Yes.
That gives us the same answer. So subtracting the 0.2%, the 20% versus calculating 80% do the same thing. And then moving from the third to the fourth one, I can see 0.8 to be the same as 1 take away 0.2.
That's a really good way to...
And so when I link it back into the question, I've got 500 multiplied by 1 subtract 0.2, which is 400%. And the reason I'm doing this is to as we go to the next slides, we start to see this 1 minus interest rate idea. And it's that I want us to kind of bear in mind when it comes to the percentage.
I hadn't actually thought of depreciation like that.
And also, if you keep doing it, that's where this negative or the subtraction in the formula comes from, because you're continually subtracting.
Yes.
And so that's kind of what I'm trying to drip, the idea I'm trying to drip in here, that we get with the negative and the subtraction as we go. Okay, so now I want to pick up with something we did similar to in the grade 10 session.
Yes.
What I talked about, the multiplicative approach. So I'm using 5s and 20s and 3 years all the time here because it just seems to be reasonably easy to do that. Second-hand cars valued at 50,000 Rand. Its value, just like the thing before, depreciates by 20% each year. What's its book value? I'm using the technical word, after 3 years. In other words, at the end of the third year. Okay, that's the kind of language that we need to think about. So this is very similar to the grade 10 one that we did last time, and I've deliberately used the color to pay attention to certain things.
Yes.
So I've started in the first line with end of year 0, in other words, the beginning.
Yes.
That's the value of 50,000 Rand. At the end of year 1, we've got this factor of 1 minus 0,2,
Yes.
which gives us the 40,000. Now, because obviously the depreciation is based on the most recent price, I'm going to take 40,000, I'm going to decrease that by 20%, and so I get 32,000. At the end of year 3, I then start with 32,000, I take off 20%, I end up with 25,600.
Yes.
And so that's that factor that I showed in the previous slide, which I'm trying to illustrate
Yes.
here. And if we go to the next part of the slide and put it all in one line, we've got the orange, which was year 1, then the blue factor, which is year 2, and the green factor, which is year 3. And that, from simple exponents, is 1 subtract 0,2 to the power of 3.
Now, if we were to unpack this in a class, firstly, once again, I think the use of color is really important in this kind of explanation. But if you were to do that calculation on the front, kinds of questions you'd ask would be, do you notice that you're losing less money every year?
Very important point.
And then draw it into compound interest. Well, compound interest, when you're gathering money, then gathering's the wrong term, isn't it? Gaining.
Making something.
And you're getting more money after each year.
So I'll pick up on that again in a later slide, but it is interesting to note that it drops by 10,000 Rand.
Yes.
But then it drops by less and less and less and less, which starts to tell us, say something interesting about what the graph would look like. And we'll get to that just now. Can we?
Yes, we can
move
move on. And what I'm going to do, though, is go back to the slide that says teaching ideas, because we've spoken about the first point that says connecting with percentage. The second point is our spreadsheets. The third point, connecting effective interest rate and percentage change. And I'm really glad you're going to talk on that, because it's not something I'd necessarily considered connecting. I just taught a formulae.
Absolutely. And I'll talk about my story when we get there, because
oh, good.
Can't believe it took me a while to figure this out.
And then, of course, linking grade 10 and 11 functions. And we spoke about that as well in grade 10. Yes. Yeah. But it's good to bring up again.
Okay, so I think we can head off to the spreadsheet. Oh, hang on. No, let's stick with the slide here first. So what I'm looking at here is this issue of the different compounding periods, which is one of the key elements of grade 11. So I'm starting off as the stem, if you want, of my question. You invest 600 Rand.
Yes.
I haven't told you for how long, what the compounding is. That's the common thing. Then I've got 3 different options in terms of the interest rate and how it's compounded. And then that's the green text. And the blue text is a variety of how long I'm investing it for. So you'll see the variation there. In the interest, I've talked about 9% per annum, compounded monthly.
Okay.
And it's just to point out to teachers, the 9% per annum is important. Interest rates are generally quoted per annum. And so I've seen often that people drop the PA.
Yes.
Because they think, well, it's compounded monthly, and so they just put 9% compounded monthly. You do need to specify the PA. And in a sense, you kind of don't read it. You almost ignore it when you read the question, but it does need to be there for completeness sake and to be completely accurate. So 9%, the other option, compounded quarterly, and then I've deliberately put a third option is 1% per month, compounded monthly. Because we need to be thinking about we don't always divide this interest rate by 12 or by 4. It depends on what it was to start with. Was it an annual rate or was it something else?
Yes.
So that's the variety I've tried to build in there. And then in the time frames, I've deliberately put some are months, some are years, and in the third case, 3.5 years. It's not all full years. And that's deliberate for us to think about different things as we go along. So let's...
Okay, why are you presenting this to us?
Because I think it's really important. If we go back to the ACT BATS idea,
Yes.
practicing these various
So you would
ideas.
encourage them to practice.
We could be
a
like, take the
variety.
first green bullet
Yes.
and take the second blue bullet and do that
Okay.
example. Then take the fourth blue bullet, the third green bullet, and go with the last blue bullet.
So you
so
actually
you
have
can
12
mix and match
questions
it.
there.
You can mix and match it as you go.
There's a card game in there somewhere.
Okay, right. And you can see how many combinations. But we're on financial maths today.
Yes.
So the formula that we'd be using there is a slight tweak on the one that we've been using previously. And I think teachers will be familiar with it, but just to point out, the I subscript N is the nominal rate per period. So by that I mean, if we're compounding monthly,
Yes.
then I little n, subscript N, is the interest rate for a month or
Yes.
a quarter or a year, depending on what we're compounding. So we will already have divided it by 12 or by
Okay.
4 or by 365 if we're wanting a
You know,
daily
that
rate.
really frustrates me is when they start saying compounded daily, because there are 365 and a quarter days in a year. And I know we don't talk about that in maths, but still.
There's actually lots of interesting conventions, and I wish we had time to talk about this, but unfortunately we don't.
No, we
Because
don't.
it's not the same everywhere in the world. Getting back to that formula, in the exponent, we've got n times m, where n is the number of compounding periods in 1 year. And I use that phrase deliberately so that we focus on in 1 year. If it's compounded monthly, then the n value is 12. If
Yes.
it's compounded quarterly, the n value is 4. And then m is the number of years. And that'll work whether we've got full years or partial years. So if I've got 3.5 years there, for example, then m is 3.5.
Yes.
And so it's consistent. It doesn't do something different now if I've now got parts of a year. Even if I say it's 6 months, it's half a year.
Yes.
So I'd put 0.5, not 6, in that particular case.
And if it were 5 months, you would put 5 divided by 12.
Good
work out
question.
that decimal.
It's a fraction of a year, yes.
Yeah.
Thanks for that. That's a horrible fraction for a year. But you're right. Okay, so if we just choose one green and one blue, I've deliberately chosen one which makes us think a little bit harder.
Okay.
And so I'm illustrating it there. I4 is the 9% compounded quarterly. That's why I've divided it by 4.
Okay.
So I4, the 4 tells me it's compounded quarterly. That's the convention. And I've already done the division
Okay.
by dividing the 9% by the 4.
Okay.
So I've got my decimal there. I substitute it in the next line. And the exponent is the 4 because there are 4 compounding periods in a year.
Yes.
And 3.5 because it's 3.5 years.
Isn't there a danger that teachers will just teach routine or procedures here? Just you put this here, put that there, plug it in, get an answer.
I think there is value in doing that.
Okay.
It is important for learners to have practice in this, but they need to understand what these numbers are representing. So when we put a 12 in place of the 4, what does that mean?
Okay.
And I think kind of saying, okay, and if learners are putting the wrong numbers in there, one of the things I've said is say, okay, you've answered a different question. If you've put 12 instead of 4, then tell me what the question was to which this is the correct substitution.
That's a fantastic way to remedy that
Okay.
problem.
So, and it gets you to think, and of course, if they put 3.5 and 4 back to front, well, it doesn't really matter in the multiplication, right?
No.
Because it's commutative. Whether teachers want to fuss about that, frankly, I wouldn't, if they've got the right numbers there. But I think it is helpful for them to kind of think, how am I working with this? And being clear that that exponent is telling you how many times it's compounding as we move through time.
Yes.
And when we look at the spreadsheet just now, I'll pick up on that again, and we can take a look.
Okay. I
on this
think we are
example.
moving
Okay, so
to
it's
this.
time to go there.
And we're going to open up an Excel spreadsheet now. And will be turning this into a Google spreadsheet a little later.
Okay, I'm going to jump to a new spreadsheet. So the ones that we've got here, you're going to have to help me here. Because I can't get to the tab I'm looking for. Oh, there we go.
Technical difficulties.
What am I being stupid? Right, so this is a different spread. This is all part of the same spreadsheet, but this is a new tab. So on the left-hand side, where the red part is the simple interest.
Yes.
And on the right-hand side, where the blue is, it's compound interest.
Okay.
Okay, so let's just take the simple example of 600 Rand. If it's simple interest, as we know before, I'm just illustrating now how the spreadsheet works. At the end of month 0, that is the beginning, I've got 600 Rand.
Yes.
And I'm just assuming in this spreadsheet that you compound it annually for the simple interest. You get interest annually for the simple interest. And so we'll see over here, there's a change at the end of the 12th month.
Yes.
We now got 10% interest, which is our 60 Rand. And that continues until the 24th month when it changes again.
And, of course, that's because there are 12 months in a year.
Now, banks don't work exactly in this way, but I think that that's good enough for us to understand where we're going with that. Okay, so the interesting part really here is the compound interest part. So if we have a principal amount, that's our starting amount of 600, an interest rate of 12%.
Yes.
What did we have just now? We had 9. Let's change it to 9. Number of compounding periods in a year, I used that phrase just now. And so this is not how many times is it going to be compounded over the whole time period. It's just for 1 year. And then we're going to look down the spreadsheet to see how much we've accumulated.
So this 4 represents the fact that it's compounded quarterly.
So in other words, 4 in a year.
Yes.
Okay. So if we do that, that's what we had just now, am I right? So end of month 0 is the starting amount.
Yes.
End of month 3 is the first time it's been compounded, because remember, it's per quarter, and there are 3 months in a quarter. End of month 6, 9, and 12. So by the end of the first year, we've got 655 Rand.
Okay.
All right. Is that right? Yeah, 655 Rand. And by where did we go? 3.5 years. Is that
Yes,
right?
I
On the
think
previous
so.
one? So 3 years would be 36 months. So am I right? It's 42 months.
Yes.
Okay. So that's how we would use the spreadsheet. Does this give us the same answer we got earlier?
Yes, I think it does.
That'll be a good thing. All right. So if we're compounding it monthly, we would change the 4 to 12. And then you'll see in this column, it now shows you end of every month.
Oh, it's like magic.
So it goes 0, 1, 2, 3, as opposed to 0, 3, 6, 9, 12.
Now, would you use the spreadsheet to teach it for the first time, or would you use it to consolidate knowledge or bring it all together?
I think it depends on how comfortable you as a teacher are with the spreadsheet. And I think it depends on how familiar your learners are with this stuff as well. So I think you could do it either way.
Okay.
The point that we're wanting to make here as well is that there's lots of at-bats opportunities here.
Yes.
Because you can just keep putting in numbers and changing and saying, okay, so if I go from 9% compounded monthly and I now compound it less frequently, let's say I go back to, or actually, imagine we could compound every half month, which I don't think I'll do that. I might bomb my spreadsheet if I do that. Let's say there are 6 compounding periods in the year.
Yes.
In other words, every second month. I don't think the real world works like this at all, but hopefully my spreadsheet won't crash when we do it. There we go. End of month 2, 4, 6, 8, 10, 12. Okay. We start to see the trends. If we compound it more often, we get more money.
Okay.
If we compound it less often, we get less money. Not infinitely more. It does tend to a limit, but unfortunately, we don't have time to get into that detail today. But Dylan looks like he's got a question for us.
Well, what you've just said is that one of the learnings that we're trying to get to understand that the more often you compound, the quicker it grows? Or is that just an incidental piece of learning?
I think it's an important piece of learning. And so I think many textbooks are set up that way. So you'll have the same interest rate, compounded annually, compounded quarterly, compounded monthly, compounded daily. And so it kind of builds to this assumption that if you could compound it every second and then every millisecond, it would just get more and more and more and more.
Yes.
But the reality is that's not the case. There is what we call a limiting value. So it reaches a ceiling. and it doesn't grow. And there's lots of fancy mathematics to prove that, and there is reference to an article that we wrote trying to make this accessible to teachers. Because the textbooks kind of leave learners thinking, well, it must just keep going on infinitely.
Yes.
So why can't I just keep compounding it, as many times as I like? And in fact, it doesn't make a difference.
Okay.
And so that's an important mathematical idea, and it's a big mathematical idea, this idea of a limit. Teachers who teach grade 12 will be familiar with limits in calculus, and so it's all connected to that. But it's kind of counterintuitive in some ways. You think it must just keep getting bigger, but in fact it doesn't.
Okay.
So that's quite interesting. It's kind of like if trees keep growing, right? Non-stop. They don't grow a little bit every second. But they don't grow infinitely huge in 1 year.
Yes.
There's only a certain amount that they grow in a year. And if you kind of think about a tree, trees don't just shoot up to Jack and the Beanstalk kind of idea. They only grow a certain amount.
Oh, it would be nice to have a money tree, keeping with the theme.
As long as it kept growing, right?
Yes. Now, while we've got the spreadsheet open, why don't you quickly show us the other two or other three sheets again?
Okay, so there's a simple interest. You type in the principal amount, and there it is connected on the graph. You can see there the y-intercept.
Yes.
And then the last time, in grade 10 when we used it, we worked with positive values because we're doing simple and compound growth. And we can type in the value there in the red, and so it's growing. I'm going to make this a bit smaller so we can see a bit more. So I'm going to change it to 300, and there we see it grows. It's linear because it's simple interest. But the cool thing about this is that we can make this a negative for depreciation, and so if we make this negative 10, what do you think is going to happen?
It'll go down.
It's going to go down because it's got a negative slope.
Yes.
Okay, and so we can type in positive and negative values there.
I do have a question here. In the beginning, we said linking percentage to decimals or changing interest rate to decimals was one of the huge problems here. Surely we're not helping them if we've got a spreadsheet that does it for us.
Oh, I guess I buy that to some extent. You know what? When I'm working with this, I want to type in as little as I need to.
Yeah, that is very true.
And so typing in the percentage makes it a lot easier. And particularly if I've got it compounded with a different frequency per annum, I want to make sure that I'm not having to type in 5 decimal places.
Yes.
So, but you make a good point about if we had a punch in the fraction, or the decimal fraction each time, we'd have to think about it. And so it might be a case of when teachers are using it, for them to be saying to their learners, okay, I'm typing in 10%, tell me what the decimal is.
Yes.
And they're just reinforcing that each time.
Yes.
No.
Okay, no question from Dylan.
So the compound interest works in the same way. So there we've got 6%. I'm not going to use the sliders because I know when you get into when you upload it on the website, they're going to disappear.
Yes.
So when I change it to 8%, it's still starting at 970, which is just below 1,000, and it's growing more steeply.
Okay.
But similarly, and I'm going to change my starting amount here to be, let's say 4,000. Okay, but now I want it to decrease. So I'm going to, at the decrease, I need to make it a negative. I think that's pretty obvious. Let's say negative. It's going to decrease by 5%, and this is per annum.
Yes.
The spreadsheet is built per annum.
Okay.
And it does this really interesting thing because it drops and drops and drops, but it doesn't seem to reach the horizontal axis.
Yes.
Okay? And I think while we're on this, we may as well just look at the numbers. As we can see the numbers going down, we see them decreasing. But as I scroll down, these are years, right? So that's 70 years over there. The numbers are getting smaller, but we never even got to 0. After 100 years, it's just under 24 Rand with compound decrease. It's decreasing that slowly. Of course, if we have a higher but negative interest rate, it will decrease faster.
Yes. Now,
and
you could use that
important.
kind of graph to talk about things like buying cars and buying photocopy machines and who's going to suffer the greatest loss versus status. To drive around a new car versus drive around a 20-year-old car, You do feel different.
You do feel different, but you pay for the privilege.
Yes, you do.
And it hits you in the pocket. So where compound interest is great when we're investing money because we're getting interest on our interest. When we are borrowing money, we are also getting interest on our interest, but that's the interest we've got to pay back.
Yes.
And so it works against us just as much as it works for us when we're investing money. And unfortunately, for many people, for most of their lives, they are borrowing money for cars, houses, fridges, TV sets, whatever the case might be, and they are paying way, way more than it's actually worth because of compound interest. And so you just see here how slowly it goes down. We're still continuing to pay off and off and off and off. Just seeing how fast, I just want to go back to the simple interest one. It drops fast because it's always reducing by the same amount.
Yes.
Whereas compound decrease is reducing by a percentage of the most recent amount.
Yes.
And so it comes down more slowly. That's an important principle to be aware of.
I do have a quick comment here, which is if you are borrowing money and you are trying to pay it off, it does make an enormous amount of sense to, even if it's just a little bit more than your payment, paying just a little bit extra every month makes that curve go down a lot more quickly than otherwise.
Absolutely. And what's very interesting is if you can pay a big amount right at the beginning, you drop it fast and then pay the littler amounts. What a lot of people, I think is that I'll put my bonus in there at the end of the year. But they've already been paying all this huge amount of interest for the previous 11 months. If they could fussbait a bit and pay more at the beginning of the year, it would drop that balance.
Yes.
And then it starts going down faster. So absolutely, financial advice, pay as much as you can, as soon as you can.
Yes.
That, for me, it's those two things. I don't need to be a financial advisor to know that that's what's going to help me pay back my debt.
If children aren't doing things like business studies and economics and accounting and stuff like that, then this is the only interaction they're going to get with loans before they go out and take a loan.
It is. And I mean, that's really the substance of grade 12 financial maths. So if you invite me back, if and when you ever do this grade 12 stuff, we can talk more about it.
Oh, fantastic. Okay, so we're going to move on to explaining effective interest now.
Okay. I said earlier that I was going to talk about my experience of it. And I always struggled to understand effective rate because it seemed, I call it slippery. You think you've got it, and then suddenly you discover that actually you don't.
Sorry, just click present for us. Thank you. And we'll go down.
Okay.
And here we have.
So one of the things that struck me in terms of understanding this was when I started playing with the numbers and getting a sense of it and not using the formula at all in the beginning. And so I'm deliberately not going to use the formula in the beginning. And the other thing I'm going to do is show how it connects to percentage change, which for me was the absolute aha moment. And when I said to somebody, but isn't this really just like percentage change? They said, yeah. And I thought, why didn't somebody tell me this long ago? It would have saved me a lot of stress. So hopefully I can share that today. Okay, so in this table, and I've deliberately tried to make this look quite similar to the spreadsheet that we've just looked at. I'm saying I'm investing 800 Rand for a year at 6% per annum compounded monthly.
Okay.
So end of month 0, 800 Rand. I use that as a convention to say this is the beginning.
Yes.
End of month 1, I have got 0.5% of interest. Because remember, it's 6%. It's compounded monthly, therefore I'm dividing 6 by 12, which gives me a half. Okay, so 0.5% is 4 Rand. And the next month, it's 4 Rand, and it's 4 Rand, and it's 4 Rand, because this is simple interest. I get the same amount based on the principal amount every month. Okay, so I'm just establishing here what it would be. And so by the end of the year, I've got 48 Rand interest.
Yes.
Okay, no surprise, 12 times 4. However, if I look at compound interest, now this part of the spreadsheet or of the table is very similar. It starts off in exactly the same way, but then it changes. Why? Because the interest is being calculated on the most recent balance.
Yes.
So at the end of year 1, I'm in the same place. We've both, simple or compound, both got 4 Rand. But by the end of year 2, it's already changed. Only about 2 cents, granted, but it's changed. And of course, that grows. It looks like the pattern is always 2 cents. It's not really the case. It's about the rounding. Finally, you do see it jumps by 3 cents from month 11 to month 12. But the key thing here, okay, as we look down the columns of interest, is that the total amount is different. So where the one was 48 Rand, the other is 49 Rand 34.
Yes.
Yes, it's not a big amount of change, but the change is really important. Okay, so here I want to connect it to the percentage increase idea. The percentage increase formula, I know learners struggle with this, but it's kind of old. New minus old divided by old. That's the way I remember it. So the new is 848. In other words, what I've accumulated after 12 months. The old is the 800 I started with.
Yes.
And now I want a percentage of what I started with. So that turns out to be 6%.
Okay, let's just say that formula again. It's the new minus the
old. The new
old.
minus the old, all over the
Yes.
old.
Okay. I'm pretty sure that a lot of teachers struggle with that as well.
Percentage increase is hard. Percentage change is difficult. So this shouldn't be a surprise. We said we were going to get 6%. We did get 6%. That's a good thing. Okay. But here's the surprise. When I do use the exact same formula of new minus old, all divided by old, with the compound amount, I take 849.34, subtract 800, also divide by 800 because that's where I started.
Yes.
The answer is not 6%.
Yes.
It's 6,168%. And that number, 6,168, is the effective interest rate.
Okay.
It's what I actually get because of this compounding every month. Okay. So it's a bit more than I was expecting, which is a good thing. Of course, if I was owing that money, it would be a bad thing.
Exactly.
So let's take a look at the next slide. So now I'm just looking at the compound interest column, and I've got 12 compoundings. That's what I'm showing with those arrows down the right-hand side.
Yes.
And then I'm highlighting here, I'm starting at the beginning, and I'm jumping to the end, and I want to do that in one step. So the effective rate is the percentage that will jump from 800 to 849.34 in one step.
Okay.
And as we see, using the compound interest formula now, I've taken the principal amount of 800 Rand.
Yes.
I'm going to put in the appropriate... I'm trying to work out the interest rate.
Yes.
That's why there's an I there. And it's I1 because it's compounded once in the year.
Yes.
And by convention, we don't write that one. And the 849.34 is the amount I accumulated by the end of the year.
Okay.
Okay, and doing the algebra and the substitution, when I solve for I get 6,168, which is what I expected.
Yes.
Okay, that's where the percentage increase and the effective interest rate are the same thing. So if I'm go over here now, I've used the formula, and it's a yucky formula, but I've used it nevertheless to prove that I get the same answer.
Yes.
And I've just put in here the same calculation from the previous screen. So we see in all three places we get the same value. And that for me was a useful way, without getting too bogged down in the formula, of seeing how all of this fits together and how effective interest rate and percentage increase work hand in hand.
When I used to teach it, I used to say that the nominal was the lie and the effective was the truth. And then I would make nominal lie, put the lie at the end with a L. And it seemed to help a little with trying to figure out where to substitute things. But in terms of explaining it, it's very difficult to explain it and understand it.
And I think if we can help learners to appreciate that effective interest rate, and it operates on 1 year, it's effective rate per annum, it's a jump from beginning to end. From the beginning of the year to the end of the year,
yes.
It must do whatever else happened with the compounding. So if we were compounding quarterly, then I'd only have 4 rows from 1 to 3, 6, 9, 12 in
yes.
my table. And I'd get a bigger number than I started with. And that the effective rate must jump from the beginning of the year and do the same thing as 4 compoundings did.
Yes.
Which therefore means that the effective rate must be higher than the nominal rate, unless we're compounding annually, in which case it's the same thing, because
yes.
there's no benefit from compounding more often.
Okay. Well, Shall we
All
move
right.
on?
So this is the tough stuff. One of the things that the curriculum talks about is connecting to grade 11 function. And so we did this in the grade 10 session where we connected the simple interest with linear growth. And so now what I've tried to do here is connect reducing balance depreciation, which is compound decrease,
Yes.
to the exponential formula that learners have learnt in grade 10, but kind of comes up in grade 11 and kind of disappears in grade 11
Yes.
all at once. So I've deliberately color-coded the exponential function and the compound interest to show the links. So there we have the exponents in a orangey browny color. The base, the b to the power of x, our base b, in financial context, our base is an entire factor, a 1 minus something.
Yes.
And then the vertical stretch, which is the coefficient.
What are the advantages of linking the exponential function to compound interest?
Well, I think one of the advantages is it shows you where the exponential function works in the real world.
That's
It's
a
an
huge
example
advantage,
of something
actually.
that grows exponentially and it impacts our lives all the time. It grows or decreases exponentially. And similarly, I think it also helps us it gives us a way of making sense sometimes of the maths by connecting it to the world, but I think it also sometimes helps us to make sense of the world by understanding the maths behind it. How come this thing has grown so fast? I thought I'd paid off some of my debt, and now I owe more than I've paid off. That's weird. But
Yes.
the maths will explain it.
Yes.
And so I think that's those are at least two advantages.
And is there a link between school maths and real world paying off loans and effective interest rates and things like that?
There is a link. And I'm sure that's why it came into the curriculum in the first place. But as I said in the grade 10 session, we only have 2 weeks to teach this. And I think that in many cases, teachers don't have the time to actually get to apply this to real world contexts. We're so busy sorting out the basics, fixing up the understanding of percentage, that we don't get to the point where learners really can engage with stuff. And Dylan was talking just now about paying off more often and stuff like that. That's only great. To understand that, we need the grade 12 mathematics. It's a real pity that we have to wait till grade 12 to get to those things. And I think some textbooks try to bring it down into grade 11 slightly, but there isn't a whole lot of time. And so teachers, I think, are in a difficult place.
We're also at the end of the year.
It is. If it's at this time in the curriculum, it's a tough time of the year.
Yes. Grade 12s are about to go off and start writing, and you've got to still focus on grade 11s. And yeah. Okay, so here we go. Here's our second-hand car again. All right, so I'm deliberately using the same example so that we don't have to get our heads around more stuff. And here's part of the table. So we've talked about this book Shall we just
already.
read out the question quickly?
Okay, thanks. You read it.
I'll give you a break. A second-hand car is valued at 50,000 Rand. Its value depreciates by 20% each year. What is the book value of the car after 3 years?
So just reminding again, after 3 years is the same as at the end of year 3. We've done these calculations already. We've shown them. So the purpose here was just to pull them back in again. And then picking up on your point from earlier to show that the difference changes. So the biggest difference is 10,000. And then it goes down. And it doesn't go down by the same amount. It goes down by smaller amounts, as we saw. Okay. If we use the compound decrease formula, we get the same thing. So we're substituting I as 0.2.
Yes.
Okay, this is annual, remember. And 3 because it's 3 years. And 50,000, which is our starting value.
Yes.
Of the starting value of the second-hand car, remember? It's not a new value. We wish we could buy cars. Well, we can buy some cars, I think, for 50,000 still. Can we?
Yeah. No.
Can't we? Okay, sorry. Right, now there's a huge amount in this box. So let's just focus on the black part first. What I'm trying to do here is connect a typical exponential expression and do those kind of graph interpretation things that we do to connect the formula. So when x equals 0, okay, and x is our time, taking from the table, when x is 0, y value is 50,000, and so when I substitute into the formula, I get that a equals 50,000 because b to the 0 is 1.
Yes.
Okay, so I get this formula here. I've got my A value already. Now I need to find my B value.
Yes.
My B is the base. And so I chose the 0.2 for year 2 and 32,000, but I could have
Yes.
chosen any of the other values, and I substituted. So my X is a 2, which is the exponent. My Y is the 32,000, which is the book value. And then I get B squared is 0.64. And then I get B equals plus or minus 0.8.
Yes.
Okay, now I think this is where there's a potential problem. Because we're thinking decrease, therefore we should take the negative.
Yeah, and that's...
But we don't. Okay, we're taking the positive. We want a positive base. So take note in the 0.8 here, it's the positive 0.8 that I'm using. And then in here I've expanded, going back to what we talked about right in the beginning, 0.8 to the x would be the same as 1 subtract 0.2
Don't
to
you
the
think
x.
that's going to confuse them more than help?
I can't help the way maths is. What I could have done here is pretended that it's only positive 0.8,
Yes.
which would have been mathematically not so correct.
Yeah.
And I know that this is a potential problem, but it's a reality that we face when 0.8 squared and negative 0.8 squared both give me 0.64. And so I do appreciate that this is potentially a difficulty here because of the because of the depreciation, but the issue is also exponential functions are not defined for negative bases. So if we go into the theory of exponential functions, we can explain why we're taking the positive base.
That's a good point to
And
revise
so
all of
that's,
that.
so it's a great opportunity, in fact, there to say, okay, which one should we choose, I suppose? And I suspect many learners will say, oh, well, clearly you take the negative because you're depreciating.
Yeah.
And it's, okay, well, let's try and plot these points. And now you're trying to, when you're working with fractional exponents and things are going to bomb out.
I think the only point in grade 11 that we actually acknowledge the negative square root of something is completing the square or something in that, right at the beginning of the year. The rest of the time we just said, square root is always positive.
Well, I guess the issue is what is this B representing? In its context, what is it? Sometimes we want the negative. So if you think about trig, there are times when you're finding the square root of something and it's in quadrant 2.
That's where it is,
and so you need
trigonometry.
the negative. In other cases, in the context, it's a quadrant 4 maybe, you want the positive.
Yeah.
And so you've got to think about what's the context I'm working with. And so it's not an arbitrary choice. There is a context which will determine it, but it doesn't mean that it doesn't have potential confusion. And I think that that's the part that I fully appreciate.
Yeah.
This is not an easy one.
You see, I was actually thinking that the confusion would be that 0.64, the square root of that is not 0.08.
Oh, there's another one. Absolutely. Typical. I mean, we all, I had to check very carefully that I got the slide right, because quite possibly I had an extra 0 there. Those are other issues. Working with decimals are difficult, and multiplying and square rooting decimals. But, in that case, I kind of think you stick it in the calculator and you get let the calculator give you the answer. The focus here is not working with decimals.
Yes.
The focus is on doing the exponential work and the financial maths work. At some other point, sort out the decimal issue if learners are struggling with it. And many are, let's face it.
Yes, they are. Okay, shall we move on?
Let's do that.
And we've got our final slide, which are some resources.
Can I just talk briefly to
Yes,
this?
please.
Okay. As I said, I did my PhD in this work, and one of the goals for me in doing the PhD was that I wanted to be able to help teachers in some way. And I wasn't doing stuff in schools, but I knew that some of the things that I'd learned in doing the PhD would be useful for teachers. And so what I set out to do was to write some teacher-friendly articles. These are not research articles. They're teacher-friendly articles in a teacher-friendly journal published by AMISA. And so they have given us permission to put these on the website. So the first 4 have been published already. The annuities and spreadsheets is really a grade 12 one. So I think we'll wait for the grade 12 show to put that up, assuming you invite me, of course. But the others, the one we put up already, the compound interest one, we talked about that last time. The timelines one is only 4 pages long, so
nice.
It's not intimidating.
Reading, yes.
The continuous compounding one is the issue I talked about earlier, where compounding even daily, every second, eventually hits the ceiling. And so a colleague in Grahamstown and I wrote that together. And there's some heavy maths in there, but we've tried to keep it chatty and user-friendly.
Yes.
And so you can skip over the maths if it's not making sense. This final one on effective rates is something I'm working on right now, and I hope to be able to send it off to the journal and get it out there, because it's kind of, some of the stuff I've shared already today is in that article. But there are a few other things in there as well, which I'd like to share with teachers as well.
Well, we will post these up on the blog, and we'll also link back to the Grade 10 show. We are almost out of time. Are there any parting comments at this point?
I want to say to teachers that I think teaching financial maths in grade 11 I think can be quite frustrating, because I think there's a huge pressure to be teaching it. And I would say if you can focus on getting learners to work with the multiple compounding periods, that they can divide by the right thing, raise to the right exponent, that's a really important thing to do, because it's very important for grade 12. Depreciation is not examined in grade 12 in any hugely substantial way. So it needs to be dealt with, and it does come in to some elements. But getting the compounding with multiple periods and getting the effective interest rate components understood well, for me, that would be priority.
Yes.
I would background the depreciation, even though it looks so big in textbooks. I think it's less important going forward than the compound growth work and the effective interest rates.
That is interesting. Yeah, because in textbooks it does look like the major things. You spend the majority of the time.
It's understandable that as a textbook author, this is something new. You would spend time on it and so develop the whole thing.
Yes.
But I think often we think because there's lots of pages on something that it's necessarily very important.
Yes.
And sometimes there's one page on something that is critical. And actually it just needs lots of time.
So think about the CAPS document. Think about your textbook. Yeah. Is this time well spent?
If learners are struggling with it, you might need to pay more time to it. You know, don't just jump over and think, well, the problem's going to go away. It's not. Grade 12 financial maths is enormously chock-a-block full.
Yes.
And so it's really important that learners are coming in with the basics in place.
Yes.
Because otherwise it's really tough in 2 weeks to cover all of that.
Yes, it is. Thank you very much for joining us.
Thank you.
Remember that you can win a phone or a tablet by submitting your teaching resource idea to competitions at digitalclassroom.co.za. We'll be watching out for them. And join us again next week. Goodbye.